Today, let's go over a medium question in the grind 75 list that I just solved by myself. Originally, I kept getting time limit exceeded and had to use someone else's solution, but today I came up with my own and got around that. So I'm really proud of that. And since this is a famous question and people were talking about how hard it was in the sections, so which is not necessarily true in my experience since I just solved it myself using ov(n) squared, and I'll just show you. So you're given an integer array nums, and the task is pretty simple. You want to find the subarray that has the maximum product and just return that, right? So why don't we start with the result, which is just going to be the maximum of nums, because in the worst case, the biggest number is the only subarray that's the maximum, and we're just going to return that. And otherwise, so we can just iterate over and get every subarray, right? And then let's call this current is 1 for j in range I length of nums. That's how you get the subarray, right? So from 2, 2, 3, 2, 3 minus 2, 2, 3 minus 2, 4, 3, 3 minus 2, 3 minus 2, 4, minus 2, minus 2, 4, and then just 4. And that's it. All right. So in that case, let's take care of some edge cases. So first of all, current, well, we can just say result equals, well, I'll show you the way that I got time limit exceeded before, which is just to say result equals max of result and math.prod of your subarray, which we're going to define it as nums of I, j plus 1, and then just return result. That works, but you're going to get time limit exceeded. Why is this showing as this? Oh, so I, instead of that, because we don't want to recalculate old subarrays that we don't want. Okay, we only want 3, 2, 3, 2, 4, 3, 3, 2, 3, 2, 4. We don't want to calculate anything before. So you're almost there, except you have a problem. And so this is where I was before. Now let's come up with a better way to do this, because this by itself, creating the subarray is ov(n), and then math.prod is another ov(n), right? So why don't we just say current, because anything times 1 is just, the product is just itself. So now instead of recalculating the subarray, let's just say current times nums of equals current times nums of j, and then result equals max of result and current, right? That's better. So okay. It's still going to be a little slow, but I'll show you what I found as a workaround. Okay. So not quite. You have this nice test case. So what you're going to do instead is, first of all, if nums of I is equal to 0, then we don't want to multiply anything by 0, because that's never going to give us a larger product, right? Compared to 0. So then we don't have to go through this whole loop and calculate this subarray from 3, 3, 2, 4, right, to the end for that iteration. Just going to make it a little faster, but that's still not going to pass. You can notice that this test case is all one number. So we can just say, if the length of set of nums, which means it's unique, there's no duplicates, right? They're all just 1, is equal to 1, then just return math.prod of nums. Okay, so and should work. Okay, so okay, and they're all not all negatives, right? So and max of nums is bigger than 0, then you can return math.prod of nums, because negative frequency of negative is negative, and that's going to give you less numbers than if you just did minus 3 times minus 3. So, oh wow, okay, last time limit exceeded. So how about let's do if current is bigger than or equal to result, result equals to current. These are just last minute tricks to get over this hump. Okay. Okay, there you go. So even small things like using the max function takes O of n, right? And then we can make this even faster by making a sorted list, which is log n instead of O of n, which is the max function. It's important to know these things. And then let's say result equals to s negative 1 because it's already sorted in ascending order. And that will make it a little bit faster. Well, not really in this instance, I guess. So the time complexity is still O of n squared, but when people say that you can't do O of n squared, that's not true. If you employ some tricks and some workarounds and really dig in there to find it out, you can make it work. So thank you for watching. I hope this was helpful, and stay tuned for more.